Hope you are doing well. Today we are going to learn the most important topic in JavaScript. Okay, so just wait for 10 seconds. I will just open all the things which are required and we can start. Hope you are doing well. Okay, when the topic is a primitive and non-primitives, really I can say that many students have the confusion what exactly is a primitive, what exactly a non-primitive. We know, right? We know, like already we had a discussion about primitives, I think few days back in detail. I will revise again what is primitives and we are going to learn what is non-primitives. Okay, non-primitive data types. So we know um, simple basic data type string, number, so boolean and undefined. These are primitives. Even we have few more things. Right now we can focus on these things to understand the concept properly. So non-primitives are arrays and objects, even functions are non-primitives. So now I'm taking this example to understand what is primitive and non-primitive. And again, primitives will deal with the call by value. This is the most important one. Primitives will go with the call by value. Non-primitives will deal with the call by reference. Okay, call by reference. So let's say first of all should understand what is primitive and what is called by value, and then what is non-primitive and what is called by reference. Where does this primitives will store in a memory and where does non-primitives will store in the memory? All these things. So before that, I will, we can just try a simple example so that you will understand easily. So I'm just taking two variables where a is equal to 10 and in the next variable I'm just taking where b equal to 20. Okay, where a is equal to 10 and where b equal to 20. And now if you do um, the b equal to 30, okay, if you do just b is equal to 30 and just check console.log console.log a value and console.log a b value. I hope everyone knows the answer, but just note down or just ping me what is the output of this program, the simple program. So where a is equal to 10, where b equal to 20, and I'm just changing the value of b so that whether it will affect on a or not kind of thing. So just tell me what is the output of a, like what is the value of a and what is the value of b now in the memory. So what then who joined? Just ping me quickly if you know the answer. And if anyone in the live, you also can ping me the answer. What is the value of A and what is the value of B? Quickly, because we are going to discuss lots of things. Uh, just don't take too much time to reply. No problem. Whatever you understand, just give me the answer based on that. You don't need to break your head. Okay, value of A is 10 and value of B is 30. Let's see whether it is right or wrong. Okay, I'm just already opening in the browser. Fantastic, just refresh and right now inspect. Okay, Yes, the answer is correct. The value of A is 10, value of B is 30. So it's simple. So this is called by value. Okay, this is called by value. Don't worry, I will explain in detail what it is. Call by value. And this A is a primitive. Okay, how we can say that this is a primitive is different. How we can identify this is happening with the call by value is different. Okay, so this number and a string and the booleans are primitives. Okay, and if we go with other example, okay, second example, let's just try. So I'm just taking another variable where x is equal to x is equal to okay value 10. What I'm doing, where x is equal to, here value is a key and this is the value. Otherwise, even if you want like count, for example, count 10, simple. Again, I'm just taking example where y equal to x. What I'm doing, I'm just copying this information, this object into y. So now I'm just trying to change the value of y dot count equal to 20. Okay, y dot count is equal to 20, and now if I do console.log, I'm just doing x dot count and console.log y dot count. So just guess what is the output of this program. So here, yes, you have said the right answer, 10 and 30. Fantastic. Here also just try, think, and just give me the answer. What will be the output for this simple program? Okay, first one is 10 and 20. Second one is what is the value? No problem, just guess it or try it. If you know the answer, just tell me. Mm, okay, Bhavita said it's 10 and 20. Okay, Bhavita's answer is 10 and 20. Okay, this is the answer for Bhavita. No problem, remaining people just try over there in the live. Just try to give me the answer. What is the value of x and y there? No, no, just guess it. Like I'm saying like x dot count and y dot count. Just try Jahnavi version. Give it a try. No problem with whether it is right or wrong. No need to worry. I will explain. Okay. Now, if you're not interested to respond, that is your choice. Okay, then we can go for. Let's see the output now. Okay, let's see the output now. Just refresh. What's happening here? X dot count and y dot count is just giving 20 and 20. Okay, so Bhavita said it was 10 and it's 20. But here, what's happening? The value is changing. X dot count is also 20 and y dot count is also 20. Here, this is behaving because of call by reference. Okay, call by reference means, okay, to understand this actually, okay, how why it is giving why x dot count is 20, because we initialize the x um, variable and it is object and the count value is 10. Here I didn't touch the x, actually I didn't touch the x, So I just copied x into y and I just try to change the value of y dot count, but why it is impacting on x object? That is the most interesting part. So the reason is these non-primitives are working based on call by reference. Okay, but what is call by reference and what is call by value? Now we are going to understand. Okay, I will explain in detail. Watch till the end so that you will learn a lot of things here. Okay, are you ready? Just at least give me confirmation. Are you ready to understand what is primitive, what is non-primitive, what is called by value, and what is called by reference? Just ping me yes quickly so that we can jump into the actual topic. So you understand the problem, right? You understand the problem. So I just stored count is 10 here and I just copied x into y and I try to change the value of y dot count, but why it is impacting on x value? X value is also coming as 20, but we are expecting it's 10. Here, see, if you copy b is equal to 20 and b is equal to, okay, sorry. Oh my God. I okay. This is the question. Okay, this is the question. So still the output is 10 and 30. Don't worry. Suppose if you copy a value of a into b and here also if you copy of x into y, here the a value is 10 and b value is 30. Here it is going to x dot count is 20 and y dot count is equal to 20. So why this is happening we are going to learn now. So let's see. Already we have learned how primitives are working. So I will just quickly revise. So for this program, just consider this program. I'm just commenting this, commenting this. Here we should understand few important things. Okay, even before going to understand call by value, okay, we should understand what is primitive. So once you understand primitive, then of course it's an easy thing. So this is a primitive. I'm writing var a equal to 10 and I'm just doing a equal to 20 and console.log console.log a value. So this is a simple example to understand what is primitive. So for that, we need to understand what's happening in JavaScript runtime environment. So you know, right? This is JavaScript runtime environment in the browser. Okay. So this it has two parts. Two parts. Here we have this is JavaScript engine and this is a browser API, and this is JavaScript engine. Sorry for the background noise. JavaScript engine. This is call stack. This is a memory stack. This is a heap memory, and here we have a JIT compiler. And if you see this is here we have a event loop. Okay, and callback queue and memory queue, and here if you have any timers kind of thing it will attach here. A lot of things are there. This is JavaScript runtime environment. So here we need to focus on these three things to understand what is primitive and non-primitive. So this is memory stack, this is a memory heap, this is the call stack. So I'm just drawing these three things again into the separate screen. So I'm just putting this is a call stack and this is a memory stack, and here I'm writing memory heap. So we have written a simple program called var a is equal to 10 and a is equal to 20 and console.log a. This is very simple program, but we should understand what's happening inside the memory. So then only we can understand the actual concept. So var a is equal to 10, of course we understand. So whenever it's going to start, whenever JavaScript engine is going to start, it will create a global execution context, right? What is this? Global execution context. And it will add, this is the memory stack, it will push a special placeholder called undefined. Special placeholder called undefined. And here, this is a global scope, and we can call this is a window object. What it is? This object, this object is a window object in a global scope. So I'm just drawing everything to understand all the topics. This is the window object. And now what's happening if we have two phases? One is a memory allocation phase and the second one is the execution phase. So right now, once you give a program to the JavaScript engine, it will create an execution context and it will be ready and it will go for a phase one. So I'm just drawing here what is happening in phase one. The phase one, it will allocate the memory. So right now we have only one variable, that is a. So and in that phase, it is not going to store a 10 or something. So it will default, it will point to undefined, this one. So here the value of a is undefined in the memory allocation phase. So it will go for a first line. In the second line, nothing to allocate memory, and line number 3 also nothing to allocate the memory. So the phase 1 has completed. Now we are going to the phase 2. This is very important, phase 2. So here this is called execution phase. The phase 1 is a memory allocation phase. Now we are into a phase 2. So here JavaScript engine will go to your code two times. The first time it will go and search all the memory allocations, variable declarations, and it will allocate the memory for those variables. And phase 2, it will do actual work. So now where a is equal to 10, so here we have a is equal to 10, that is the initialization part. So we need to assign 10. So then what will happen? It will store here the value. It will store the value 10, and it will change the it will change this reference here. So it will just remove the connection here and it will take the value from this memory allocation. So this is the memory stack. This is the a memory stack. This is a memory stack, and this is a call stack. Okay, and this is the heap memory or memory heap. Memory heap. So A is undefined initially in the memory allocation phase, and when it comes to the execution phase, the value of A will become 10. So here it will be at 10. It will be 10 in that object. It will replace that value here. So then now if you want to understand what is primitive, just focus for next 2 minutes. It's easy. So here the next statement is A is equal to 20. The next statement is A is equal to 20. Then what will happen? And in this situation, there are two ways. One is we can replace the value here. Another thing is you can push another value into the memory stack as a 20. Okay, this is one option. Or you can replace value in the same memory as 20. Either you can go with a, but we will think in that direction. So how JavaScript is working means it is not going to replace the value. This is the most important thing. It is not going to replace the value in the memory stack. Once you assign a value, you can't update it, you can't edit it. That the nature is called primitive. So a value is 10 initially. So if you reassign a is equal to 20, it is not going to change this value. It is not going to change this value. This 10, you can't change it. So what JavaScript engine is doing, it is just pushing a new value into the memory stack and it will pointing to that memory. It is going to point to that memory, that memory. So now value of a will be a 20 that is coming from this memory allocation. So we can't change this value. Once you assign a is equal to 10, then you can't change it. Suppose if you do a is equal to 30 and it will go and push another value in the memory stack as 30 and it will change this reference. So that means we are not able to change this value. We are not able to change this value. So all this primitive data types works in the same way. So we are not able to change the value of this a string or a number or a boolean once you assigned. So that nature is called a primitive. You can't change this value. Okay, understood? Because you can't change a value in the memory once you assign to some particular memory. You can't change this value. That is called primitive. So hope you guys understood what is primitive. I will take the confirmation from students. Team, do you understand what is a primitive? Quickly just give me a response. If you have any question, no problem, you can ask me. Okay, quick. So yes, thanks for the confirmation. This is primitive. This is primitive. Okay, the nature is a primitive. Then what is call by value here? Call by value here. That means here a is equal to 10 and a is equal to 20. So now I'm going to explain this program call by value. Of course, it's very close to the first program, right? Once you understand primitive, then it's an easy way to understand what is called by value. So now I'm just taking the different example where a is equal to 10, where b equal to a and b is equal to 30, and later we are going to check console.log a and console.log b. So let's see, I'm just redrawing the same program one more time. So I'm just taking the new paint. Of course, we can draw it quickly. It's not a big deal. You should also practice. If you just watch, if you just listen, you feel that you understand. But if you want to remember, you should do practice. If you don't do practice, you can't remember anything, you can't learn anything. So let's understand what is called by a value with this example, simple example. So now again, if you give this program to JavaScript engine, it will create global execution context, right? And it will push undefined into the memory stack, undefined into memory stack. And this is here we have a window object in the global scope. Even you can check in the browser also. And now it will start a phase one. In the phase one, it will allocate the memory for all the variables. Here we have two variables a and b, so it will allocate the memory for a and b. So if you see a, and it will point this a to this undefined, this will point a to this undefined, so the value of a will be undefined, no problem. And again, it will allocate the memory for b also, so b, and here surprisingly it will point to the same undefined, okay, same position, so the value of b also undefined, undefined. So once, because third line b is equal to 30 may be considered log a and considered log b, so those we don't have anything to allocate the memory for those lines. So now we have a undefined, b undefined. Once memory allocation phase is completed, we are going to do the phase 2, that is called execution phase. Execution phase. Now a is equal to 10. A is equal to 10. Well, first, what will happen? It will, because we know understand primitives, it will allocate a new memory every time. So here it will store 10. It will store 10, and the a value will become 10 once you change the reference from this to this. Okay, a value will become 10. Okay, a value will become 10. So now again, b is undefined, and if you are doing b equal to a, b equal to a, what will happen here? It will allocate another memory here. It will allocate another memory here. So it will store b value as 10. Okay, observe carefully what is happening. What it will do? If you do b is equal to a, it will copy this value of 10 into this, like you're giving a new value, you're taking, this is taking value 10 and it is giving to b, so it will allocate a new memory for b, and now you can see b value also 10 at this moment. At this moment b value is at 10 in the memory, so b value will become 10. In the next line, what you're doing, b equal to 30. So here already we completed call by value. So if you see, whenever you do b equal to a, it is just copying the value from a memory a, because a is pointing to this memory allocation. So whenever you do b is equal to a, it is copying the value of a into b, exact value what is there in the a, that is 10, and it is copying into b. That is called call by value. Simple. But this is very simple. Why we need to discuss a lot here? So once you understand call by reference, then you will understand what is the importance of this discussion. Call by value. So just remember, so whenever you do b is equal to a for primitives means a number, a string, or a boolean or undefined, this kind of thing. So whenever you do copy like b is equal to a or something from one variable to another variable, it is just to copy the value. What is the value of a? 10, and it is just copied into b. And now what we are doing, b is equal to 30. So whenever you do b is equal to 30, so already we understand in the last example a is equal to 10 and then a is equal to 20. It is going to allocate the new memory, right? So here also same. It will allocate a new memory for to store the b value. So here the value will be 30, and this reference for the b will change from the previous memory allocation to this new memory allocation. So now this is going to point, this b is going to take the information from this memory allocation. So we lost the connection here. So now the value of b will become value of b will become 30. So if you see now, if you do a console.log um, console.log of a and b, so we don't have a problem. We can guess what is the output easily. Console.log of a and console.log of b. So right now at this particular moment, what is the value of a in the memory? That is 10, so that you will get the output as 10 in the console. And at this particular moment, whenever you are executing console.log of b, at that particular situation, the value of b is there 30. So it is just pointing to that memory. This is simple and a primitive and call by value. But once you understand how what is non-primitive and what is called by reference, then you will understand the importance of this discussion. So that just wait, only 50% is completed in this discussion, and now we are going to enter into the actual important thing that is called call by reference. So before going to that, just give me one more time the confirmation. Do you guys understood or not? So we understand primitive means once you allocate memory in the memory stack, you can't change that value. So instead, you will store a new value and you can change the like reference for that. And if you just do a copy, it will exactly copy the value. It's not going to do any kind of twist and turns here. So let's see, we are going to understand what is a non-primitive. What is a non-primitive? If you want to understand what is non-primitive, so we should go back and understand one important concept that is called pointers. So here, what I'm saying, this is a non-primitives. If you want to understand what is non-primitive, as I said, we need to understand one important concept called pointers. So I think you have studied maybe C language, if I'm not wrong, in our graduation. Just tell me at least how many of you remember the concept called pointers? I'm asking how many of you know about pointers. So while watching this video, yeah, just recollect what is pointer. If you learn in your academic thing or anywhere. So Varshan said he know what is pointer. Okay, very good. Remaining students, very good. Bhavita also said yes. So then you can understand what is non-primitive easily, like anything. So let's jump into the topic. What is a non? Okay, it stores the address of a memory. Very good. The pointer means it will store it is not going to store the direct value. It will store the address. Okay, how it is working and what is the importance of that? Let's jump into the topic. So now, if you see, I will just go back. See, even I forgot the fundamentals of C language, this thing, but I will explain in a easiest way. Suppose, just imagine some memory is there. This is so memory allocation name is A, and the value is a 10. Okay, value is 10. So for each and every memory has the address. So for example, this address of this memory is 2000. Suppose you have taken another variable b and just so for that also definitely it has some other memory allocation. Suppose a 3000 something. So whenever you do copy like b equal to a, b is equal to a. So if it is a call by value, what will happen? It will copy value 10. It will just copy this value into B. So the B will become 10. This is one thing that is simply called by value. But what is pointer means? What is pointer means? It is not going to store, it is not going to store the value actually. It is going to store the address. So if this variable is stores the value of another variable, then it is normal variable. And if this variable b, so pointer means normally we will refer with a star mark in C language. So if you just declare star b, then what will happen? The simple mm, so in C language I'm saying int a is equal to 10. If I explain something wrong, correct me. Int b is equal to 20. Of course, I will explain the same thing in JavaScript. So if you do b equal to a, okay, b equal to a, the simple, suppose if we don't have the star, if you don't have star means that is a normal variable. Normal means normal variable. So b is equal to a, then what will happen? It will store the value exactly. So if you printf percentile d comma a and printf percentile d comma b, you will get the value. Suppose int b is equal to 20. Instead of that, if you just try to store a value, what will happen? It will copy only a value 10 into this memory. So a value will become, or a value is 10, and b value also 10, because it is just copying the value. But suppose if you declare it as a pointer, I just forgot the syntax, but I try to recollect it. So if you do int star b is equal to a, means the b is a pointer now. B is a pointer now. So if it is a pointer, it is not going to store the value. It is not going to store the value. It will store the address. It will copy the address. So here the b value is not 10. It will store the 2000. Okay, it will store 2000. So this is called call by reference. That means you are just storing the address, that is a pointer. So whenever, if you call console.log console.log b, so if you're trying to read the value of b, it is not, what it will do, it will go and take the value from this address. It will try to read value from this address. So I forgot some syntax in the C language, so I'm just trying to explain what is pointer. So pointer means it will store the address of another variable into this variable, that is pointer, simply. So whenever you try to read the value here, it is not going to return 2000. What it will return, it will go and check this address, and it will go to that address, and it will return this value. Okay, the same thing will happen in JavaScript. So I will explain it now with a beautiful example. So I'm just opening again into the another paint. So if you see what will happen here, this says, again, this is the call stack, this is a memory stack, this is a memory heap. Now we are going to see what is happening in memory heap also. So here this is a memory stack, and this is a memory heap or heap memory. This is called call stack. Okay, call stack for this program. So non-primitives like pointer. So here we can deal with this example. So let's see what will happen. So what you are taking, call by reference the count of 10 or something, whatever it is. So let's store x and y, and so this simple program. Okay, let's see. So where, just a minute. Okay, where x is equal to a count, some object, and that is at 10. So first, initially, whenever you give this program to JavaScript engine, yes, it will allocate the memory and it will push the global execution context to here in the call stack. This is called global execution context. Observe carefully, global execution context, and it will push a special variable called undefined here. Undefined here. And this is a window object, as we know already. We are in global scope. So again, we are going to deal with the phase one. In the phase one, it will allocate the memory. So here we have two variables, that is x and another one is y. Let me add the information properly here. Here, if you see in the phase one, it will allocate the memory for all the variables. So here we have two things, where x and where y. Here also, in the phase one, the same way. So it will allocate the memory for x, and that is point to this undefined only in the memory allocation phase. So it doesn't bother about in the memory allocation phase whether you are storing a string or a number or something. Only if you just declare a function, that is the different case. Apart from that, if it is a variable, it doesn't bother about what you are storing, whether it is a number or a string or some boolean or undefined or something. It will do the same process. So x value will become undefined. X value will become undefined, and in the same way, it will allocate the memory for y. It will allocate the memory for y. The y value is also undefined because it is pointing to the same position. X also will point to this memory and y also will point to the same memory. Now the interesting part is going to come. So we are going to be in a phase 2. We are going to understand what is happening in phase 2. The phase 2, this is actual execution process. We understand that this object and arrays and functions are non-primitives. If it is a non-primitive, the actual information is going to store in the memory heap. The actual information is going to store in the memory heap. So if you see where x is equal to count of 10, this is the object. This is going to store the information in the heap memory. So the the information is like that. Just copy this. This is the most important thing. So it will store here. It will store this value here. Okay. And this is actual information. So imagine the value of this memory allocation is at 2000. Okay. But don't think that this is going to directly connect with this heap memory. No. So even though your information of this X is going to store in the heap memory, it will push another information here. What it will do, observe carefully, it is going to read the address of this memory. What is the address of this memory? Address of this memory is at 2000. Address of this memory is 2000. So whenever you store the address into that memory, then it will become a pointer, right? So just remember, if it is storing the address, just give a star mark for understanding purpose. It is a pointer. It is a pointer. So 2000, and again it will point to this. So this is going to read the information from this. Okay, this is non-primitive. Non-primitive. Okay, this is called reference. Okay, it is reference. I will come to what is the meaning of non-primitive and what it is exactly called by reference. So here, if you see, what is the value of x now in the memory? So normally, if you just try to understand the example, like where a is equal to 10 something, and if you give a is equal 10 and a is equal 20, then here you can see the exact value 10 and 20 here. So now guess it is whether the value of x will become 2000 or it will be a count of 10. So I'm just storing as a pointer. So if you see, if I do x is equal to count of 10 in the phase 2, it is going to allocate the memory for this object in the memory heap, and it will store the address of this memory into the memory stack. And now guess what will be the value of x here, whether it will be 2000 or count of 10. Just tell me, just guess it. If you know, it's already you know. If you know pointers, you know the answer. Okay, no problem. So if you see, the value of x is not 2000. Value of x is the value of this memo. What is the value here? And it will go to that memory because it's a pointer, right? It's a pointer. So whenever you try to read information from the pointer, whenever you try to information from the pointer, it is not going to give the value which is there in that. It will give the value which is there at this address, which is there at this address. So whenever you call x, it will go to this address and it will bring this information. It will bring this information. So the value of x is what it is? Count only. That is at 10. Okay, that is 10. This is very, very important. Just tell me understood or not, because if you don't understand this, you can't understand what I'm going to teach in next few minutes. Just give me a confirmation. Srijan, Babita, and Jahnavi, and who are watching this video live, or even if you watch this video later, just give me confirmation whether you are able to understand this or not. Understood? Okay, super, good. Now, if you see the interesting thing in JavaScript, so now what you are doing, where y equal to x, where y is equal to x, just now go back and recollect what you are doing. Where a is equal to 10, where b is equal to a, then I said it is going to copy the value of a into b. So value of a is 10 and it is going to store in b the value of b also 10. So later we are doing b is equal to 30, so again it will just reassign the value 30 in a different memory allocation. Just recollect this what we have discussed. Now come back here. So here what is happening now, whenever you do y equal to x, y is equal to x, y is equal to x, see the magic here. This is the most important topic in JavaScript, maybe in all the programming languages. Whenever you do where y is equal to x means it is not going to allocate a new memory here. So maybe people will think that okay, it will allocate a new memory like this. People will think that okay, I will show you what is exactly in next 2 minutes. So maybe the address will be 3000, it will store 3000. No, what it will do, it will just copy this address into this memory. That's where the problem will come. What it will do, it is also a pointer. It is also a pointer. And if you do var y is equal to x, it will copy this value 2000 into here also 2000. Okay, here also 2000. And now the value of y, just imagine here, this is the most interesting part. So the y is going to point from undefined to this memory, this memory, this memory. X is pointing to this memory, and x value, suppose here also, this here also, which is referring to x also 2000, now which is referring to y also 2000. Now tell me what is the value of y. So how the value of x is count of 10, like it is go to this memory and it will say, okay, this is a pointer, so it is not going to read 2000. Immediately it will go to this address that is called 2000 and it will give the this value to you, that is count of 10. So here also same, for y also it will go to this memory. Okay, here this is a pointer, this is the pointer. Just imagine whenever you are storing the address, that is the pointer. So just always just put a star mark, that is called a pointer. So 2000. So now if you call y again, this y is also referring to the same memory in the memory heap. Same thing. Suppose if you see, for example, if you know the power star Pawan Kalyan. So if you say Pawan Kalyan, we are referring to the same person. If you say power star also, it is going to refer to the same person, right? In that way. So 2000 here x 2000, it is going to referring to the same address memory. Again, y is also referring to the same memory address. This is where the interesting things will happen. So here y also, what is the value of y? What is the value of I? So this is also count colon 10. So y also, the count is equal to 10. So at this point we have no problem. So var x count of 10 and var y, of course here also if you see the y, it is just calling to the same memory. We don't have any problem. But now the actual problem will come here. So if I do y dot count is equal to 20. So what I'm saying, y dot count. So I'm just trying to change y dot count. So what it will do, if I do change the value of this count is equal to 20, so again it will store here, right? If we do y dot 20, so y means this one, and it will go here, and dot count means this one. You're saying you're giving a new value called 20. So that means this is 20, right? This is 20. Y dot, this is 20. So now what happening, just observe carefully. Y is also referring to the same memory and x is also referring to the same memory. So that x value, even though you didn't change the x, even though you didn't touch, you didn't write x dot count, but you changed y dot count, and that y dot count is 20. And if y dot count is 20, here the count value is 20, that you can easily guess it guess it, right? Because this y is going to refer, y is just referring to this memory, that is a pointer. The address is 2000, it is go and read the value from here. But if you see, surprisingly, x, if you call x dot count, what will happen? X also go to this memory, this one. The value of this is 2000, this is the pointer. Again it will go to the same person, the value of count is 20. So automatically, indirectly, even though you don't want to change the value of x, but because this is happening by call by reference, then what is happening? So because it is this, both x and y are referring to the same memory in the memory heap, because x and y are referring to the same memory in the memory heap, because you just copied this value with the help of call by ref is a non-primitive. This, if it is a non-primitive like object or array or a function, it is not going to copy the value as 10 2000. It is just going to copy the reference. What is the reference? Address. It will copy the address, so that x and y will point to the same memory, same thing in the memory heap, so that if you do x dot count, you will get a 20, and again if you do y dot count also 20. So you are not interested to change the value of x count, but you have changed the y value, y dot count is equal to 20. But here this is happening with the call by reference. It is just dealing with the pointers and call by reference indirectly without your intention. It is going to change the value. So the value of x will become 20 and y also will become 20. So here you didn't change, you didn't write x dot count. So even if you do x dot count is equal to 30, automatically y value also change. Y value also change. So observe carefully. This is the program right now. I will show the same thing in the browser. Just refresh, you see 2020. So even sources, so just try to debug. Of course we can't see that in a we can't debug the heap memory, we can't see that, but you can see the global execution context, a value of x and y, right? X and y. So I think we should use simple, okay, 1 minute. Instead of x and y, it is reflecting a dot count also. So it means we are referring to the same memory. So just refresh. So if you see in the global scope, you have a undefined, again bb is also undefined in the memory allocation phase, right? Right now we are in a execution phase. Now if you see, so count is equal to 10, so count value is 10, still b is undefined. Okay, whenever you copy, so whenever you do bb is equal to aa, so if you see count value is 10, this here also count is 10. So now I'm changing bb dot count is equal to 20. I'm just trying to change this value only, bb dot count, but indirectly it is going to change this value also, because it is working with a call by reference. So if you see the boom, you just did bb dot count is equal to 20, but automatically AA is also reflected. AA is also changed. So AA dot count is 20, BB dot count is equal to 20. So whenever you are dealing with the non-primitives, you should understand this concept. Otherwise, we are going to do lots of mistakes. Okay. And now I will tell you what is a non-primitive. Non-primitive means, if you see, you are able to change the value, right? Once you store the value in the memory, in the heap memory, you are able to change the value in the original memory. So here, when it comes to the stack where a is equal to 10, here you store the 10, you can't change this value. Instead of that, you should take another memory and you should store the new value. But when it comes to the non-primitive, it is allowing us to change on the same position. The count is equal to 10, right, previously, and here the count is 20. We can replace at the same location. We are going to use the same memory. Here we can't use the same memory. We can't use the same memory here. Where a is equal to 10, this memory is different. Whenever I do a is equal to 20, it is just copying to the new memory. That means you can't change this value. That is called a primitive. That is called a primitive. When it comes to the non-primitive, yes, we are changing at the same location, count 10, and we can increase the value or decrease the value or we can change the value of count here itself. That is called a non-primitive. So here we covered four things: what is called by value and what is called by reference, and indirectly we understand what is a primitive and what is non-primitive also. So I'm not sure how many of you understand clearly. So just ping me, give me your confirm. I think we lost. I think 1 hour completed. Okay, no problem. I can catch you at a live. So if you understand, just ping me understand or understood or not. So I'm trying to explain one more thing. So even if you watch this video later time, so please give me your opinion. Like if you understand clearly, just ping me that understood. If you still have a confusion or if you didn't understand anything, please ping me what is your question so that I will try to give a more explanation. For that only I'm asking. Otherwise, just enjoy the learning. Okay. See you and bye bye. See you in the next session again. I'm going to stop the recording.